Welcome to the Metabolic Classroom. I'm Professor Benjamin Bikman, a biomedical scientist and professor of cell biology. Today, we are once again discussing Glucagon-Like Peptide-1, or GLP-1, an increasingly appreciated and even essential gut hormone with profound metabolic effects, which is why we just keep revisiting the topic. Today, we're going to review some of its effects at regulating appetite and glucose control, just to help remind you of why it's important and why it's a helpful hormone in the first place, but also put it in context of obesity and share some evidence that I haven't before when I've talked about GLP-1 in the past. But with all of that in mind, we're going to put a different spin on it in today's lecture by really focusing on natural ways to boost GLP-1. So how can you get your GLP-1 to work a little bit better for you? Now, first of all, let's start by just revisiting what GLP-1 is and what it does. GLP-1 is an incretin hormone secreted by the L cells of the small intestine. It does so in response to food intake. So when we eat or drink things, we're going to get a GLP response to that. Now, GLP-1 in turn plays several critical roles in overall metabolic function. One of the primary functions, which is not often discussed, is the ability of GLP-1 to inhibit glucagon secretion. Now, glucagon is insulin's opposite. Whereas insulin wants to lower blood glucose, glucagon wants to increase it. And it's an interesting problem in people with diabetes that they actually have too much glucagon consistently. And glucagon acts to increase GLP-1 by glucagon acts to increase glucose by telling the liver to break down its stored glucose, which is glycogen. Now I'm saying lots of gluc and glyc words, so hopefully you're keeping them all straight. So GLP-1 suppresses glucagon secretion, which in turn will lower the amount of glucose coming from the liver, which finally is going to help stabilize blood sugar levels. Another crucial function of GLP-1 that makes it so metabolically favorable is that it will delay gastric emptying. By slowing down how quickly food is leaving the stomach, GLP-1 can prolong a feeling of fullness, reducing overall food intake. Naturally, if you have more bulk in your stomach, you're going to be less inclined to eat more. Along those lines, and certainly complementary to this effect, is that GLP-1 activates satiety centers in the brain, directly acting on the hypothalamus to promote satiety, further reducing hunger and reducing the risk of overeating. Now, GLP-1 acts through very specific receptors distributed throughout the body, including the ones I just mentioned. You have GLP-1 receptors in the pancreas, where glucagon is made. You have them in the stomach and GI tract, influencing the rate at which it's moving food through the stomach. You have them at the brain, the blood vessels, etc. Because of this, the activation of GLP-1 receptors will play a crucial role in all of these effects that I've mentioned. This is how it's influencing glucagon secretion. This is how it's influencing the hypothalamus in the brain and regulating, and in the brainstem, regulating the neural pathways associated with hunger and energy balance. A key physiological effect of GLP-1 that we've not discussed is its interaction with the vagus nerve. And the vagus nerve is what connects the brain to the gut. It transmits signals between the gut and the brain. By activating these, what's called a vagal afferent, GLP-1 can enhance this sense of fullness, leading to a natural tendency to just eat less. The person can control their appetite a little more. Perhaps a final comment here on GLP-1's effects is that it has been also shown to have some anti-inflammatory properties by directly interacting with immune cells, like macrophages, for example. So this hints at some evidence and some role of GLP-1 that goes beyond the canonical metabolic regulation, touching on the inflammatory and the immune, which, as you know, having been a student of previous episodes, once you start manipulating inflammation, you are also influencing metabolic function. Now, one of the reasons I support interventions to increase GLP-1, and even in some instances can see a use of the GLP-1 based medications, is that there's evidence that GLP-1 levels in individuals with obesity may be impaired. One of the studies that you can access in the show notes by being an insider is a study by Ranganath and colleagues. And they found that postprandial or post-meal GLP-1 secretion in response to oral carbohydrate intake was significantly lower in obese individuals compared to lean. Sorry, excuse my almost sneeze. So they found that the GLP-1 secretion in response to carbohydrate consumption was significantly down in individuals with obesity compared to those who are lean. But interestingly, this difference was not observed following the consumption of fat. So a little more, the study examined 6 lean and 6 obese women and found that while both groups experienced an increase in GLP-1 after consuming carbohydrates, the response in the obese individuals was remarkably blunted. Just to put this all in perspective and to sort of act it out a little bit. Remember, GLP-1's primary effect is to, well, one of its primary effects is to stimulate a sense of satiety. So a person eats a given amount of food based in part on how high the GLP-1 goes. That's going to in part influence how satiated or how full they feel or how much the brain is telling them that they don't need to eat anymore. When the groups ate fat, they had the lean group and the obese group eat an equal amount of fat. They both had a roughly comparable degree of GLP-1 response. This suggests that the satiety signal that would come from eating fat is roughly similar between the groups. So whether you're lean or you're obese, fat is going to be equally satiating. But the contrast really became apparent when they ate carbohydrates, that this really starts to emphasize the role of diet and our unique responses to what we eat. But when the groups ate carbohydrate, the lean group had a GLP-1 response that was about 3 to 4 times higher than that seen in the obese group. This is important. And thus, with this evidence in mind, we ought to be pointing the finger at GLP-1 to try to help people who struggle with obesity to turn that around. To say all of this another way, you have a lean group and an obese group. They eat the exact same amount of carbohydrates. In the lean group, thanks in part to a very robust GLP-1 response, this suggests they would have an easier time after eating that carbohydrate, feeling like they're full, and then pushing the plate away, if you will. In contrast, the obese group, having eaten the exact same amount of carbohydrate, now has such a modest GLP-1 response that they do not get as much of a satiety signal from that given amount of food, of that carbohydrate that they ate. And thus, it's no surprise that they may come back to the table a little sooner, or rather push their plate away, but rather than showing that as a sign of being done, they say, "Can you give me more?" Collectively, these results from this fascinating paper act really to underscore the importance of the composition of diet, the macronutrients that we eat in optimizing GLP-1 levels, but also it emphasizes the benefit of appreciating the differences that people may naturally feel. That someone who's struggling with body fat levels and struggling with obesity, part of what they struggle with may be this reduced response to what they're eating with GLP-1. What normally would have told them to stop eating just isn't loud enough of a signal. Now, we're going to revisit this idea in just a moment when I highlight another study, but there are some other concerns. There are concerns with GLP-1 medications that are worth highlighting in order for us to really appreciate, and this is something I've done before, but I'm revisiting it briefly just for us to appreciate why we want to find natural ways to leverage GLP-1 in our favor. Now, I've certainly made the case, I hope, that some people may struggle with having higher GLP-1 levels, and this may be driving them to overeat foods, which may be in turn driving their obesity. But the GLP-1 drugs do give me cause for concern as a biomedical scientist. So some of these drugs, like semaglutide, which is the main molecule in Ozempic and Wegovy, have really gained popularity because they will effectively promote weight loss, but the concerns are significant enough that I really think they need to be highlighted. One concern is what happens with lean mass. A paper that was published that indicated that the use of semaglutide resulted in 40% of the weight lost coming from fat-free mass or lean mass. Now, that's not to say it was all muscle and bone, because fat-free mass or lean mass does also account for some water loss. But suffice it to say, there would be some tissue loss from muscle and bone. And depending on the age of the individual, that may be tissue loss that they would struggle greatly in order to regain that after it's been lost. Another concern that was really highlighted in a paper just published is mental health. There is a very statistically significant, and I would add very meaningful, increase in poor mental health outcomes. Like the risk of depression goes up almost 200%, and the risk of suicidal behavior and anxiety goes up by a little over 100%, so it doubles. This is, I think, particularly relevant in the midst of what we may consider a kind of a mental health crisis, that we are adding fuel to the fire here in this culture where a lot of people are struggling with mental health. Additionally, another concern is the issue of the return of sweet cravings, that over time, some individuals regain their appetite for sweet and, the sweet, gooey foods that are so, the cravings for which have been so reduced, they come back. Naturally, that results in a return to these older eating habits. That is a consequence of assigning our self-discipline to a syringe, that the person hasn't really developed the mental, not fortitude, but approaches and tasks and behavior to help them deal with these cravings. They didn't have to deal with it. The drug gave them an artificial sense of self-discipline that wasn't there. But just to really highlight that particular study, when they initiated the use of the drug in this study, and they were measuring sweet cravings as one of the outcomes, they found that at about 6 months on the drug, the sweet cravings were greatly reduced, an enormous drop. At about a year, they were still really dropped, but then at 2 years, it had returned totally to normal. This also happens to be the time about 2 years on where 70% of people on the drug decide to get off the drug. Maybe it's because of the nausea that they feel, because of the greatly reduced gastric emptying where the food is sticking around longer. It could be that there's the return of sweet cravings where they feel like it's just not really working anymore. Regardless, back to the idea of the lean mass loss. Once a person gets off the drug, that weight starts to come back, but they've lost weight from two different categories. They've lost fat mass and they've lost lean mass. One of those weights returns very readily, one does not. Okay, now that I have convinced you, I hope, that there is a case to be made for worrying about someone's GLP-1 levels, but that some of the modern drug approaches may not be the best way to address that reduced GLP-1, let's talk about some natural ways to boost GLP-1. And to my great delight, I'm able to rely on evidence from my own lab to talk about this. In no particular order, one option is yerba mate. My lab at BYU conducted research, and we just published this, showing that yerba mate, the traditional herbal tea, significantly increases GLP-1 levels. It was an increase of about 40 to 50%. Now, there are multiple compounds in yerba mate that have been shown on their own to increase GLP-1, but the one we focused on in this study was one called ferulic acid. But we found that ferulic acid alone had a modest effect on stimulating GLP-1 from the L cells, but that its microbial metabolite, in other words, the product of the microbiome converting ferulic acid into dihydroferulic acid, increased GLP-1 significantly. When we incubated the dihydroferulic acid on the L cells, we found that whereas the ferulic acid had a modest, about 40% increase, when we put on dihydroferulic acid, it went up like 3 or 4 times. So a huge increase. So with all of this in mind, in addition to other lines of evidence, drinking yerba mate regularly could be a practical and effective way to increase GLP-1, controlling appetite and naturally then supporting improvements in metabolic health. One other comment about yerba mate is that it actually, some of the compounds in it are known as bitter tastants. And a bitter tastant are these molecules that we taste and they taste bitter. We not only have those receptors of taste in our mouth, but we actually also have those taste receptors further in our gut. And when they're stimulated, they actually promote a greater satiety on their own and reduce sweet cravings. So there's a bit of a 1-2 punch when it comes to yerba mate. The combination of the GLP-1 secretion and then just the bitter tastants acting as their own signal, helping to control sweet cravings. Now, ironically, speaking of sweet, another natural method to increase GLP-1 is the rare sugar allulose. So I can cite another study from my lab where we studied allulose and looked at its ability to secrete or induce some GLP-1 increase. Now, unlike traditional sugars, allulose does have a benefit as a rare sugar in that it does not spike blood glucose or insulin, but instead actually acts in a way to really promote some appetite suppression. We found that there was a significant increase in GLP-1 levels with allulose consumption. And in fact, it was quite a rapid effect. There's a remarkable outcome from this that we've seen. In fact, we are in the process of attempting to publish a case study where we look at the use of allulose in type 1 diabetes. Now, one of the lesser known attributes of type or aspects of type 1 diabetes, indeed something I hinted at earlier, is that as much as we look at it as a disease of too little insulin, which isn't wrong, another valid view is that it's a disease of too much glucagon. Now remember, GLP-1 inhibits glucagon. And so what people are seeing who have type 1 diabetes, where they're monitoring their glucose and their insulin levels rather exquisitely, that with allulose consumption, it is such a robust regulator of glucagon and blood glucose in turn that they are able to not only enjoy better glucose levels, but require significantly less insulin to maintain those glucose levels. So as a kind of brief aside, one of the areas of research for me that excites me the most is actually the use of allulose in the context of diabetes. Okay, now those are some clever kind of hack methods or biohacking methods, to be clear, in order to kind of leverage your guts for you to increase GLP-1, namely yerba mate and allulose. But a low-carb diet could be another way to support GLP-1 production. One of the citations here is a study by Hall and colleagues, which investigated the effects of a low-carbohydrate meal compared to a low-fat meal on postprandial GLP-1 levels. So the study randomized individuals, these 20 participants, and they not only followed the diet, a low-carb or a low-fat diet for 2 weeks, but then they also studied them and looked at their blood levels immediately following a meal. Firstly, the results showed that the low-carb diet led to significantly higher just fasting basal states of GLP-1. So in a normal fasted state, those that were adhering to the low-carb diet had a significantly higher GLP-1 level. This is important because it could start to hint at why a low-carbohydrate diet appears to help improve cravings and satiety better than a low-fat diet does. But they also had another component to this study, which was having them eat a singular meal, a low carb meal or a low fat meal. And in this narrow window of time immediately following the meal, once again, they saw a significant difference where, importantly, they were isocaloric, so the exact same number of calories. And they found that the low carbohydrate meal elicited an increase in GLP-1 that was about 3 or 4 times higher than the same number of calories, but that found in the low fat meal. Now, importantly, protein was similar between the two. So the meals were only manipulating the macros of fats and proteins. The evidence is quite clear then, based on this study and some other lines of evidence, that one good way to naturally increase GLP-1 secretion is control the carbs while prioritizing protein and not fearing fat. Now, finally, with regards to nutrition, collagen peptides have also been shown to increase GLP-1 secretion. In some animal studies, the collagen peptides were shown to, yes, increase blood glucose metabolism and blood glucose control and improve insulin sensitivity, but perhaps facilitating those outcomes, they increased GLP-1. This is, I think, relevant because as much as we have a culture that appreciates collagen supplements and collagen peptides, we often only discuss those or that supplement as a way to improve skin or just general tissue function. We don't often talk about its ability to stimulate GLP-1. So perhaps one of the unappreciated aspects of collagen is as a metabolic benefit as well, given the GLP-1 effect, which is significant. All right. Now, one final thought of a natural way to increase GLP-1 is actually sleep. Sleep quality and circadian rhythm, depending on when you're sleeping and how you're sleeping, can also play a role in GLP-1 function. Specifically, and much to my chagrin, if you haven't heard me bemoan my poor sleep before, you can hear me do so now. I'm a terrible sleeper. But poor sleep has been associated with impaired GLP-1 responses and impaired hunger. So to be perfectly clear, a bad night of sleep actually blunts your GLP-1 levels, which, as we extend through all of the effects of GLP-1, can result in a reduced satiety signal, in other words, greater hunger, which is going to set you up to just be craving and snacking that next day, which, as you continue to do, especially later into the afternoon and evening, is going to set you up to further even have worse sleep. Because, of course, if you go to bed in a hyperglycemic or an elevated glucose state, you activate your sympathetic nervous response, and your heart's going to be beating harder and faster, and your body temperature is going to be higher, all of which is going to combine to make sure you have a miserable night of sleep. Now, to make things perfectly clear, GLP-1 is a powerful hormone, and it regulates hunger, it regulates glucose metabolism, and a host of other processes in the body. And while GLP-1 medications are undeniably effective at promoting weight loss, they come with concerning side effects like a 40% loss of lean mass for every pound lost, mental health risks, including significant dramatic increases in depression and suicidal behavior, and of course the return of sweet cravings, and then the potential for all of that weight to come back, particularly as just a lot more fat mass. Instead, focusing then on natural ways to increase GLP-1, such as yerba mate, allulose, generally a low-carb approach, collagen peptides, and prioritizing sleep, all of these can provide what I believe to be a safer, yes, more subtle, but more sustainable strategy for maintaining metabolic health and helping GLP-1 work for you. By prioritizing these smart dietary choices and the lifestyle habits, I believe that's the most effective way to help GLP-1 production work just a little better. In the event that you are one of those people who may be getting a blunted GLP-1 response to what they're eating, maybe you just have to eat a little differently, be a little smarter about it. And hopefully some of these ideas can help you do so. I hope you found this material helpful. as always, please let me know what you've thought about it. Please consider becoming a subscriber, an insider in the community, and share this information with a friend, especially if it's one who may be tempted or already on some of these drugs. Until next time, more knowledge, better health.